I got the privilege of introducing MOMA to you, so our workplace, Department of Molecular Medicine. So we are both a part of Aarhus University and a part of Aarhus University Hospital, and hence of Central Region Denmark. And as Lay said, it will both be me, Morten, and Kasper who will speak. See if I can. Yeah. So I'll give the introduction. Kasper will talk a bit about the GeoMx equipment and the spatial sequencing, and Morten will talk some about data analysis. We are placed at the edge of Skyby Hospital, so there was this nice picture. And we have extensive dry and wet lab facilities, some of them shown on the pictures. This covering that we are around 150 people. We do basic translational and clinical research in mainly cancer genomics, sex-linked disorders, bioinformatic methods developments, and other things as well. Around a third, which has been a strongly growing number as well, do molecular diagnostics for the hospital, and also included in here are some NGC employees. So some of the main focuses for the hospital is on hereditary disorders, so colon cancer, breast cancer, heart diseases, a large focus of cancers of unknown primary, but now also more generally metastatic disease. And we house a sequencing facility for the National Genome Center and are part of that. So a lot of our research is based on really tight clinical collaborations, and we have paid nurses, etc., at hospitals helping with collection of samples for our analysis. We have several rooms filled with freezers that house extensive tissue banks for bladder cancer, colon cancer, and prostate cancer. So one of the special opportunities here is that we have these tight links, and we also have physicians, doctors doing from other departments visiting, not visiting, but being partly employed by us, and we kind of a hub for molecular medicine in that regard, and an extensive network across the hospital. So a little bit about next generation sequencing at MOMA. We've had a sequencing facility since 2010. As I said, we're now part of the National Genome Center, so with the whole Genome Sequencing Center West. This slide looks strange, so I'll just move ahead a little. Okay, we currently have 4 MiSeqs and 4 NovaSeqs, which are really the workhorses for our sequencing at the moment. We have bought a NovaSeq X Plus. We are waiting for its delivery, so that will increase our throughput to up to 8,000 gigabases per day, 8 terabases per day, equivalent of 80 whole genome sequences at decent depth per day. We have one PromethION, so Oxford nanopore machine that does a single molecule long read sequencing. It has an impressive throughput as well if you fill up all the flow cells. And we of course have an extensive amount of other machines to help us out, including a number of robots, etc., for high throughput, and also machines for doing single cell sequencing, such as the 10x Chromium controller. So a little bit about how sequencing is developing, and to no surprise, it's increasing year by year. So this is a graph of the total number of samples being produced by the sequencing facility here at MOMA. And that includes both, so the yellow line there includes both the diagnostic and the research part. And you can see both diagnostic and research are growing, and NGC is expected to fill up more and more of the diagnostic throughput, and probably will reach 6,000 to 8,000 whole genome sequences as part of NGC in 2023. A little bit about our bioinformatics setup. We have about 10 bioinformatics staff and about 20 employed doing bioinformatics research, perhaps a little bit more. We have comprehensive computational infrastructure for automatic handling of data as it comes out of our sequences. Our clinical pipelines are accredited, and that includes variant calling, but we also have standard pipelines for other types of analysis, expression analysis, etc. And as for the other parts of our work here at MOMA, we have very close ties between research and clinical development, which really facilitates rapid implementation of new techniques also in the clinical setting. We are highly dependent and have a very good collaboration with a part of the Genome Deco high performance computing facility, which we use for the vast majority of our NGS data analysis. So we really hope to be able to exploit this setup for the single cell sequencing as well, and learn from and build upon the experiences we have from making these robust clinical pipelines. Now I can't shift my slide. That works. So we have some experience in single cell sequencing in the cancer setting, which has been spearheaded by Lars Djurskud Andersen. He's been working on sequencing, so single nucleus sequencing in the bladder cancer sequencing for several years. And one example is this paper that just came out a few years ago, where Sophie is first author. A more personal interest that also involves Morten Muli, that will speak shortly, is on downstream analysis of some of this data, where we have developed a method for inferring microRNA activity from single cell RNA-seq, so from the expression of mRNAs, exploiting that the targets of a microRNA expressed in a cell, the mRNA targets of a microRNA expressed in a cell, will often show correlated changes in abundance. So they move up and down depending on whether the microRNA is highly or lowly expressed, and we can use that to infer expression of individual microRNAs. And this is an example from a mouse single cell atlas showing some tissue-specific microRNAs that can be inferred using this technique. And that was actually all from me.